So now that we have the basics down, we have the inverse of an exponential, and we have how to say it, and each of the different terms, we can now evaluate. We have this new equation, so how would we pronounce this? We pronounce it the log base 2 of 64. So, basically when we are evaluating, we're trying to find out what x is, or what this equation is equal to. Right? So we know that if we can find out what this is equal to, that's the same thing as evaluating the log base 2 of 64. So, the first thing we are going to do is change it to exponential form. So basically how I like to think of this is you basically just drag the 2 up to the top and push the x up to the subscript. So you have now, you get rid of the log, and you move the base up, so then you have the argument is equal to the base to the exponential. So this is a lot simpler. It's the same exact equation, we just switched it to exponential form, from logarithmic to exponential. The next step we are going to do is basically now solve for x. But if it's in the exponent, how exactly are we going to solve this in the x? First, it's pretty simple. If you have 64, we want to get it down to a base of 2 because we want like bases. That's always what we want, like bases. So we know 64 is the same thing as 2 to the 6th power, right? We got 2 to the 6th is equal to 2x. So, based on the property of equality,
the property of equality states if there are any two logarithms with the same base, then the arguments must also be equal or the same.
If they're like bases, then that means the exponents are equal to each other. And now we can cross out. And now we have 6 is equal to x. Does that make sense? Perfect. Okay, so we got our next problem. Is write it again. We go log base 3 of 81. And what are we trying to find? The x. We want to find the x. So, what we're going to do first is we're going to change the exponential function. We're going to bring the 3 up here, bump the x up, cross out the log. So then we have the 3 is the base, leave the argument by itself, and we move the exponent to the exponent spot. So we got 81 is equal to 3x. Does that make sense to everyone? Perfect. Okay. And next, as I have written right here, we are going to find like bases. So we want like bases. We want to find 3 and 3. So we got 3x is equal to what? 3 to the 4th power is 81. So if we have this, we can cross out and solve, or you can just look at it and say, okay, if the 3's are the same, if they're equal to each other, then obviously the x has to be equal to the 4. So we know x is equal to 4. And then how would you say this? You would say the log base 3 of 81 is 4. Okay, so that is logarithmic functions. We got it all down, and thanks for joining us on web class today. See you later. I'm Professor Brady.